Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about a technique known as mesh analysis. Okay, so what is mesh analysis? Mesh analysis is basically a technique that is used to find the value of the unknown currents, okay, unknown currents which are flowing in the circuit, okay, flowing in the circuit. So what do you understand by the term mesh? Okay, so mesh is basically a special loop that does not contain any, so that doesn't contain any other loop. Okay, for example, this is your mesh. Okay, because this is your mesh 1, okay, because it does not contain any other loop inside it. Similarly, this is your another mesh, okay, mesh number 2, okay. Also, this is not a mesh, okay. The reason for that is because it already contains 2 other loops, so we cannot say this is not your. So this loop is not your mesh, okay. This loop is not your mesh. Second thing that you need to remember before applying mesh analysis, that mesh analysis can only be applied on planar networks, okay. Planar networks. Okay, so what is a planar network? So planar network is basically a network that does not have any, crossovers between its branches, okay. So if the branches are passing each other or crossing each other, then we can say that that network is a non-planar network, okay. For example, this network is your planar network, okay, planar network. On the other hand, as you can see, there is a crossover over here, okay. So we can term this network as a non-planar network. It means that we cannot apply mesh analysis over here, okay. So the third thing that you need to remember, a mesh analysis uses KVL and Ohm's law in order to evaluate the value of the currents which are flowing in the network, okay. So we can also find the number of meshes using the formula E is equal to B minus N plus 1, okay. So where E stands for number of equations, or you can say meshes, okay, or meshes. B stands for the branches in a circuit, electrical circuit. N stands for the number of nodes in a network, okay. So as you can see, in this particular electrical network, we can clearly see that there are a total of 4 nodes. So N will be equal to 4, since there are 5 elements which are present in this network. It means that the number of branches will be equal to the number of elements, which is 5, okay. And so it means that the number of equations or meshes will be equal to E is equal to B minus N plus 1. It means that 5 minus 4 plus 1, which is equal to 2, okay. So from diagram also, from the network also, we can clearly see there will only be 2 meshes. This will be the first mesh, okay, and this will be your second mesh, okay. Now, in order to evaluate the value of the currents in the branches, we need to use KVL and Ohm's law, okay. So now let's apply mesh analysis to identify the values of the current in this particular network. Okay, so first we will draw the meshes. So this will be your mesh 1. Okay, this will be your second mesh. One more thing that you need to understand is while drawing mesh, we will take a same direction. Either it can be a clockwise or it can be your anti-clockwise. Okay, let's say the current flowing in this loop is your I1 and the current flowing in this loop is your I2. So it means that we can say that on applying KVL and Ohm's law, 4 volt will be equal to 1 into I1 plus 2 into I1 minus 2 into I2. The reason of negative sign is because the I1 and I2 currents are both working in the opposite direction. It means that 3I1 minus 2I2 will be equal to 4 volts. Okay, so this will be your first equation. So then in the next case, you can clearly see the value of I2 will be equal to, since 2 ampere current is flowing in the opposite direction of I2, it means that I2 will be equal to minus 2 amperes. Okay, so this will be equation 2. So it means that on substituting the value of I2 in the first equation, we can clearly get, so 3I1 plus 4 will be equal to 4, and it means that I1 will be equal to 0 amperes. Okay, and I2 is already given to us, which is your minus 2 amperes. Okay, so I hope it is clear how we are solving this particular problem. Okay, so now let's solve one more problem to understand mesh analysis deeply. Okay, so let's use mesh analysis in this particular network. So as you can see, this will be your first mesh. Okay, and the current flowing in this mesh is your I1. Okay, similarly the current flowing in this mesh will be equal to I2. Okay, so on applying KVL, we can see that 15 minus 5 plus 10 I1, okay, plus 10 I2 minus 10 will be equal to 0. Okay, so it means that 15 I1 minus 10 I2 is equal to 5 volts. Okay, so that is coming out to be, on taking 5 common on both sides, we can say that 3I1 minus 2I2 is equal to your 1 volts. This is your first equation. The next one we have, okay, on applying mesh analysis, okay, on applying KVL in the second loop, we can get, so 10 volt will be equal to 20 I2 minus 10 I1, so which is coming out to be minus I1 plus 2 I2 is equal to 1. This is your second equation. Okay, so using equation 1 and 2, we can clearly see that 2 times of I1 will be equal to 2 and I1 is equal to 1 amperes. Okay, so substituting the value of I1 in this second equation, we can clearly get the value of I2. So the value of I2 will be equal to 1 amperes. Okay, so the value of both the currents I1 and I2 are coming out to be 1 ampere. So I hope it is clear. So that's all for today, guys. In the next lecture, we are going to discuss about the concept of super mesh. So that's all for today, guys. I will see you in the next tutorial.